There is no life without water. In fact, the earliest forms of life originated in water. Aquatic organisms cannot survive without water. If a fish is out of water, its life is immediately in danger. Terrestrial organisms on land, such as human beings, animals, birds, are also very dependent on water for their survival. Plants also require water for their life and growth. The use of water can be divided into consumptive use and non-consumptive use. In consumptive use, water is consumed and lost as a resource temporarily, but it does appear somewhere else. In this use, the quality of water may change. In non-consumptive use, the water is again restored to the original source without much change in the quality. When a boat in a canal or a ship in the ocean moves, the water is used for navigation. But the original quality of water is not changed. Water used for hydropower generation is non-consumptive. We are naturally interested to know where the water comes from and where it goes. In nature, water is stored in different forms. In oceans, deep in the Earth's crust, ice caps and glaciers, rivers and streams, lakes and ponds, underground, in soil, and the atmosphere and biosphere. Water is present in plants, animals, and in our own bodies. The normal distribution of water stored in various compartments is as follows. Ocean water is not directly usable. The water in the Earth's crust, ice caps and glaciers is not in a convenient place for us to use. Thus, the usable fresh water is only about 0.6%. The water stored in rivers and streams is very little. Water is transferred to the atmosphere from oceans, rivers, lakes, vegetation, soil, and other compartments. Water precipitates from the atmosphere. Yet, water vapor in the atmosphere maintains its average value. Glaciers and snow continue to exist from year to year, though they melt and feed the rivers. Similarly, ocean levels remain almost the same. Is this not a riddle? Any compartment should have become dry through constant use, but it does not. In nature, there is continuous movement of water between oceans, land, and atmosphere. It goes through a cyclic movement. This remarkable cycle is called hydrologic cycle. This cycle fills the deficiency created in various compartments. In the hydrologic cycle, the important phases are evaporation and transpiration, precipitation, surface flow, and groundwater. The sun's radiation is the driving force behind the hydrologic cycle. The heat from the sun causes evaporation from oceans, rivers, snow, and soil. The evaporation increases with the temperature during the day and decreases with a drop in temperature during the night. Evaporation takes place from all surfaces which are wet. Evaporation from saturated soil surface is almost the same as that from a free water surface at the same temperature. As evaporation continues, the atmosphere becomes more humid. Humidity slows down evaporation. There is a maximum limit to the amount of water vapor that can exist in any space at a given temperature. The space is then said to be saturated. Excess vapor after saturation will condense into water droplets. In the rainy season, humidity is high and clothes take a long time to dry. Clothes dry faster in summer because of low relative humidity. Relative humidity is the percentage ratio of the actual vapor pressure to that of the maximum vapor pressure in the given space at the particular temperature. This is a measure of how much more water vapor can be held by air. If relative humidity is 60%, it means that 40% more vapor is required to saturate the air. A drop in temperature may lead to saturation with the same amount of vapor present. If we pour ice-cold water in a tumbler, we find that drops appear on the surface of the tumbler. If the cold surface is below freezing point, the water forms ice crystals or snowflakes, as in a refrigerator. When wind blows through air close to the water surface, the wind carries away the vapor along with the air. The relative humidity decreases and therefore more water will evaporate. The circulation of air masses in the atmosphere is complicated, mainly due to the Earth's rotation. A resulting significant force is Coriolis force, which deflects the direction of wind. Because of such deflections, strong trade winds occur between the latitudes 10 degrees and 20 degrees in both the hemispheres. Owing to these strong trade winds, the evaporation in these latitudes is maximum. Not at the equator, though the equator receives more solar radiation. Other significant changes in air mass circulation are brought about by variations in landforms and their positions relative to water bodies. Only very small quantities of water absorbed by the root systems of plants remain in the plant tissues. Almost all of the remaining water is returned to the atmosphere as vapor through transpiration from plant leaves. This is the principal mechanism by which the precipitation on land is returned to the atmosphere in the hydrologic cycle. The evaporation from oceans is about 460,000 cubic kilometers annually. It would take about 3,300 years for all the ocean waters to evaporate if the water is not returned to the oceans by some processes. The evaporation from soil together with evapotranspiration from vegetation is about 40,000 cubic kilometers annually. The period over which moisture stays in the soil will vary from 2 weeks to 1 year. The annual evaporation from lakes and rivers is about 20,000 cubic kilometers. The evaporation from India's land area is estimated to be approximately 1,500 cubic kilometers annually compared to 60,000 cubic kilometers globally. In the free atmosphere, the temperature decreases as the height increases. The temperature of rising unsaturated air decreases at the rate of 1 degree Celsius per 100 meters. At large heights, the relative humidity may become 100%, and the air becomes saturated with the vapor already present. Depending on the height and temperature, the water may exist in the form of vapor, clouds, water drops, or in the form of snow or ice. The water and snow will come down to the ground as precipitation, as in the case of the tumbler experiment. Precipitation may not necessarily occur where evaporation occurs. The vapor may be transported to remote places. Maximum precipitation takes place in the equatorial regions because the trade winds, with large amounts of vapor, converge in this region. In the warm sub-equatorial regions, the cool, low humidity air comes down and gets warmed up. The evaporation is more than precipitation. That is why deserts like the Sahara are found in this region. The circulation of convective air is also greatly influenced by large land masses such as mountains. Moist air rising on a mountain cools, and there is precipitation on the windward slopes. After crossing the mountain range, it comes down and picks up more moisture on the leeward side without precipitation. Thus, some deserts or drought-prone areas are formed on the leeward side of mountains. This effect is called the rain shadow effect. The famous Death Valley is in the rain shadow of the Nevada mountain range in California, USA. Similarly, Rayalaseema in Andhra Pradesh and Rajasthan are drought-prone areas. Precipitation may occur in small quantities for many days in a year, depending on the climate and circulation. Or, in the equatorial regions, the precipitation may occur seasonally during a limited period in a year, such as the monsoons in India. The world's rainiest place is Cherrapunji, where rainfall may reach 3 meters in a year. Being close to the sea does not guarantee adequate rains. For example, during the southwest monsoon in India, Tamil Nadu state does not receive much rain, though it is on the sea coast. From the water resources point of view, we are interested in the precipitation reaching the land surfaces on the continents. The annual land precipitation is about 110,000 cubic kilometers. This is more than the evaporation from all land surfaces. It might appear that each year 50,000 cubic kilometers of water are transported to land from oceans through precipitation. However, this is not the case. Eventually, the excess water flows into the oceans through several paths. It can be a surface flow such as rivers and channels. The remaining water flows through various depths in the ground as groundwater flow. Including snow melt in India, the total water as rain is estimated to be 4,000 cubic kilometers. But the distribution of rain is such that heavy rains occur in the Himalayan region of Arunachal Pradesh, Nagaland, Meghalaya, Manipur, Tripura, Mizoram and Assam. The topography of large areas in this region does not permit intensive cultivation. During the early part of rain, some water is intercepted by the vegetal cover such as forest trees, foliage, plants and crops. This is called interception storage. As the rain continues, the water fills up the depressions such as puddles, ditches, tanks and lakes. This is called surface retention. Some water flows over the ground surface and is called surface runoff. However, the surface runoff depends also on the nature of the soil surface. Any soil usually has pores varying in size from very small capillary pores to relatively large non-capillary pores. During rainfall, some water moves through the soil surface into the soil. This passage of water is called infiltration. Some of the infiltrated water may move laterally through the upper soil layers until it meets a stream channel. Such a flow is called interflow. The capillary pores help in the retention of water in the soil. The interconnected non-capillary pores permit water to flow downwards by gravity towards the groundwater. The downward flow of water is called percolation. This water is called gravitational water. When all the pores in the soil are filled with water, the soil is said to be saturated. When the soil is saturated, surface runoff begins to occur. The total surface runoff in the hydrologic cycle is about 30,000 cubic kilometers. The total surface water flows in India is more than 1,850 cubic kilometers. Part of this is stored in reservoirs and tanks. A portion is used through diversion and pumping. About 1,400 cubic kilometers of water flow into seas. The zone of saturation may extend to depths of 3 kilometers or more. If this zone of saturation is not confined by any overlying impermeable material, the free but irregular water surface is called the water table. The water table approximately follows the ground. Such a geologic formation permitting water to flow from one place to another is called unconfined aquifer. The pores in the soil above the water table are connected to the atmosphere. When the rains subside, water from the larger pores of the soil may evaporate, but it may be retained in the capillary pores in this zone of aeration. This water is taken by the plants through their roots. The water table may go down. In some areas, the water table has a gradient and intersects the stream channels of the basin. Then, groundwater may discharge into the streams in the direction of the downward gradient of the water table. This is the groundwater flow, also called base flow. Sometimes groundwater is overlain by an impervious rock or stratum. Such an aquifer is called confined aquifer. The confined aquifer contains artesian water. The water in the confined aquifer is under pressure because of the weight of the overlying stratum and the existing hydrostatic pressure. If a well penetrates into the overlying material, water will rise and form an artesian well. During percolation of water to an aquifer, soil and porous rocks act as filters. They do not allow bacteria and other suspended impurities to pass through. Therefore, groundwater is generally clean and safe. The percolating water may dissolve minerals from the rocks. Certain mineral combinations give good taste to the water, and this water is highly valued for drinking. The hydrologic cycle will be closed when the remaining precipitation water flows back to the oceans from the groundwater regions. When the water table is fairly inclined and above sea level, water will flow from unconfined aquifers to the oceans through the permeable boundaries. Water from confined aquifers seeps into the seas more easily, since the water in the confined aquifer is already under high pressure. In the global hydrologic cycle, the total groundwater flowing into the seas annually is about 20,000 cubic kilometers. The processes described above are natural ones, which have been going on since the beginning of the hydrologic cycle on Earth. However, in recent times, human activities have introduced interference in the natural hydrologic cycle. These include air pollution, soil erosion, and silt in water. Sulfur dioxide, oxides of nitrogen, and other gases emitted into the atmosphere may lead to acid rain. Lead emitted from exhausts may become part of precipitation. Thus, air pollutants also become part of the hydrologic cycle. When water has a high silt content, aquatic plants and animals are affected. With excessive removal of groundwater, the water table goes down. In areas such as the Mehsana district of Gujarat and Coimbatore district of Tamil Nadu, the overexploitation of groundwater is causing concern. If the water table is below the sea level, seawater will intrude into the aquifers, which then become saline. This is the case particularly in Saurashtra and the Pennar Basin. Therefore, development of water resources has to be planned carefully without interfering too much with the natural hydrologic cycle.